Okay, I'm seeing this inverse sine and this stuff here, so I think I'm going to go with a trig sub. So I'm going to draw me a triangle, and I'm going to label the sides, this being the hypotenuse and this being x, so that this is the square root of 1 minus x squared, and here's my theta. So I'm going to have sine theta equal x over 1, and dx is going to be cosine theta d theta. Now, as I go to do this substitution, here I have the inverse sine of x. So right here is where I can take the sine of both sides, and I would have theta equals sine inverse of x. So I can replace the numerator, the stuff in the parentheses, with the theta. So that's going to be theta to the fifth over square root of 1 minus, our x was sine theta, so sine squared theta, and then our dx is cosine theta d theta. Now let's see what we can do to simplify that. This could be replaced with cosine squared theta underneath the square root, and then we could square that, and then we could square root that and leave us just cosine theta. It'll cancel with that cosine theta. So I'm left to integrate theta to the fifth d theta, which is just a power rule in reverse. So I'm going to have one higher power, and I need the reciprocal of that power, and then plus a constant. Now let's go ahead and replace our theta. Well, we have it right here. Theta is inverse sine, so this is going to be 1/6 and inverse sine of x to the sixth plus a constant. Now we had another option here, and we could have used u substitution if we let sine to the negative 1x be our u, because what is the derivative of inverse sine? It's 1 over the square root of 1 minus x squared dx. And so had we seen that, we actually could have let this be u to the fifth then, and then this other part is our du. So just two different ways to look at it, arrive at the same place. Not all of the time do students recognize the inverse trig function derivatives, and so trig sub would work. But if you recognize that, that was probably less work to arrive at our answer.